Hello everyone, myself Mr. Sunil Kumar Singh, graduated from BIT Sindri in 1994 and MTech from IIT BHU in 2000. I am presently working as Head of Department of Mining Engineering at Bilaspur College of Polytechnic, Bilaspur. I have total more than 20 years of teaching experience in the field of mining engineering. I am present here to give a lecture on open pit design, and these are the contents: introduction, terminology, bench parameters, stripping ratio, pit slope stability, haul road design, design of waste dump, ultimate pit design, references. Introduction: open pit mine is an excavation or cut made at the surface of the ground to extract ore which is open to the surface for the mine's operational time. In order to expose and mine the deposit, significant quantities of waste rock have to be excavated and replaced or moved at the lowest possible cost with maximum profit are highly expected. The planning of an open pit mine is closely related to economics, which in turn is influenced by several geological and mining engineering conditions. It is different from open cast mines in that in an open pit mine, the waste material is dumped within the boundary of the mine, where outside the boundary of the mine, whereas in open cast mines the same is dumped within the boundary of the mines. This is the basic difference. Here we are discussing about the design of an open pit mine. An open pit design is elaborated in several stages that consist of designing or planning a scheme or set of alternative schemes, followed by an evaluation and selection of the optimum scheme. The most economical final pit design depends on the factor that cannot be controlled by the mining engineers, such as the geometric outline of the ore body, the distribution of ore within the ore body, topography, maximum allowable slope angle, etc. Because these parameters are natural, not man-made, that is why they cannot be changed by any mining engineer or any worker or any planner, and they have to be considered during the planning and designing of an open pit mines. And this is the flow diagram of designing of an open pit mine. From the top we see that first of all it is excavation stage. Excavation stage contains the various parameters like model of ore body, topographical data, geological data, geotechnical data, geophysical data, etc. And these are the input data that is available naturally. These data cannot be changed. After that we come to conceptual stage. Conceptual stage means it comes to ore characteristics, mining method that have to be selected, whether it is open pit, whether it is open cast, whether it is a stripping method, etc. Production capacity, targeted production, it is either in million ton per annum or 1000 ton per annum, just like. And life of the mine. Life of the mine means the total operating life of the mine. Site facilities, infrastructure, that is number of machineries available, etc. Capital cost estimate, the total cost of development of an open pit mines is also calculated. Then unit operation in cost operating. What are the various process of estimation of cost? Finally, then we come to design stage. Design stage means optimization of economic pit limit and mining sequence. Optimization means we have to invest minimum money and getting maximum profit, and the operation in such a manner that there should not be any loss for operation of mining. And transportation, sequence, equipment, these are the some parameters, equipment performance, and final stage is the evaluation stage, evaluation and comparison with alternatives, then final it is optimal design. So, basically after the designing of an open pit mine, we come to evaluation. If we have alternate methods for mineral excavation and we compare economically, efficiently, that which method is more suitable for economical, ecological, environmental and social aspects, and after that we select the ultimate pit design, final design. Now, some terminology associated with open pit mines. First of all, bench. In open pit mines or open cast mines, bench is just like a ladder form, but ladder is a very short dimension, it is very larger dimension and it forms a single level of operation above which mineral or waste materials are mined from the bench phase. Basically, bench provides a working platform not only for machinery, but also for workers, and various operations have to be carried out on bench. In bench, we consider bench height. Bench height is the vertical distance between upper and lower surface of a bench. It is influenced by the size of equipment, mining selectivity, government regulations and safety. Bench width. Bench width, it is the distance between crest and toe, means crest of bench and toe of bench on a surface. Then face angle, it is the inclination of a face of the bench with horizontal, and then crest, it is the upper part of a bench. Similarly, toe is the lower most part of a bench face. Bench slope or bank angle, horizontal angle of the line connecting bench toe to bench crest, and this is berm. Berm, horizontal shelf or ledge within the ultimate pit wall slope, left to enhance the stability of a slope within the pit and improve the safety. Berm interval, berm width and berm slope angle are determined by geotechnical investigation. Basically, berm is here regarded as safety berm. It is placed at the corner of a bench or a ramp to prevent the falling of heavy vehicles that moves over the bench to haul road. A working bench is one that is in the process of being mined. That is, here the whole operation like drilling, blasting, loading, transportation and stabilization of bench is carried out continuously throughout the life of the mine. Again, cut. The width being extracted from the working bench is called cut, means those width of bench that is extracted. Width of working bench, it is defined as the distance between the crest of the bench and the new toe position after the cut has been made. It is dependent on the width of machinery, whether bench may be single lane or double lane. Haul road is the travelling load. road in an open cast mine. First of all, it is developed because the whole transportation operation is carried out through whole road, and this road should be maintained throughout the life of the pit. Life of an open pit, it is continuously maintained, as the whole transportation system depends upon this. Overall pit slope angle. The angle measured from the bottommost bench toe to the topmost crest. It is the angle at which the wall of an open pit stands as measured between horizontal and imaginary line joining the top bench crest with the bottom bench toe. It is determined by rock strength, geological structure and watery conditions. The overall pit slope angle is affected by the width and grade of the haul road. Grade means here gradient of the haul road. Naturally, if the width is more, the overall pit slope angle will be less. If width is less, the overall pit slope angle will be high. Those parameters or terminology has been presented here by a diagram, as we can see from the diagram that what are the various terms and parameters in an open pit mines. You can see bench face, bench height, bench width, toe of bench, crest of bench, pit floor, berm angle, berm width, etc. Now, come to bench parameter. In bench parameter, we consider face. It is an exposed area from where the overburden or mineral ore is extracted. Crest. Crest is the highest point of the face. Toe, lowest point of the face. Bench, the step or floor accommodating the mine machinery. Bench height. Each bench has an upper and lower surface separated by a vertical distance h equal to the bench height. The bench height is determined by the size of the mining equipment and formation of the area. The loose oblique soft rock allows bench height up to a shovel reach. In hard and very strong rock, bench height is usually between 10 and 40 meters, but in loose rock and soft rock it is restricted to 1.5 to 6 meter. Here bench slope. Bench slope or bench face angle is the inclined plane of the bench made an angle with the horizontal, or the average angle that a face makes with horizontal. The exposed subvertical surfaces are known as bench face, and bench face are described by the toe and crest. The crest and toe bench face angle alpha, the bench face angle can vary considerably with rock characteristics, face orientation and blasting practices. In most hard rocks pits, it varies from about 55 degree to 80 degree. Now, bench floor. The exposed bench lower surface is called bench floor. Again, bench width. The bench width is the distance between the crest and toe measured along the upper surface. Bank width. It is the horizontal projection of bench face. There are several types of benches. A working bench is that one which is in process of being mined. Here continuously mining process is carried out. The width being extracted from the working bench is called cut, and the width of working bench WB is defined as the distance from crest of the bench floor to the new toe position after the cut has been extracted. Clearly, the bench is a working place or moving place of an open pit mines, and this is depicted by the diagram. Bench geometry, you can see crest, bench width, toe, bench face angle, bench height. There are in this picture 3 benches has been described. Bank width you can see, bench height, toe, etc. Again bench parameter, we come to overall pit slope. Overall pit slope is the angle at which the wall of an open pit stands as measured between the horizontal and an imaginary line joining the top bench crest with the bottom bench toe. And geometrically overall pit slope angle can be computed as alpha or delta tan inverse N b into B h by N b minus 1 to B h plus N b into B h tan b beta. Here it is the overall slope angle, N b number of benches, B h bench height, B w bench width, beta bench angle in degree. Here it is considered that each and every bench is of equal height and equal width, but in actual practice any bench is not in equal height or equal width because of variation in the nature of strata and rock conditions. It is diagrammatically presented as overall pit slope. You can see an imaginary line that has been drawn from the bottommost toe and topmost crest, and this line whatever the makes the angle with the horizontal is called overall pit slope angle. Stripping ratio, it is very important term in every surface mines. It is the ratio refers to the ratio of volume of overburden or waste material required to be handled in order to extract some tonnage of ore. It is expressed in meter cube per ton. Stripping ratio is volume of overburden removed divided by mass or tonnage of ore extracted. Here volume is taken in meter cube, not in ton, because the overall strata is not throughout in composition. There is the variation in their densities. That is why we cannot determine the mass at directly due to variation in density. In designing an open pit mine, another type of stripping ratio known as break even stripping ratio BSR, that has to be taken into account. This stripping ratio is directly related to the cost of whole mine, which is an important parameter considered for open pit design. BSR can be calculated as revenue from ore, that is from selling of ore, the money we have obtained, minus cost of mining excluding stripping cost, means only cost of extraction of ore, not overburden, and divided by stripping cost, that is the cost associated with the removal of overburden. In open pit mines, the stability of slope means bench face has to be maintained throughout the life of the mines. For the purpose, various measures are taken, because the stability of whole mining depends on the stability of slope here, because once there is the failure of slope, it will damage the nearby bench, lower bench, not only the machinery as well as the whole working, and even it causes damage to workers, and workers may get injured. The slope of the pit wall is one of the major element affecting the size and shape of the pit. The pit slope helps determining the amount of waste that must be moved to mine ore. The pit wall needs to remain stable as long as mining activity is in that area. The stability of pit wall should be analyzed as carefully as possible, and for the purpose we calculate or determine the factor of safety for different type of failure. If the factor of safety is below 1, then we take the remedial measures against the failure of slope, and these includes the bolting, the draining of slope, and control blasting, etc. Here are the possible failure of benches in an open pit mines. We can see plane failure, wedge failure, circular failure, toppling failure, and again rock fall. In plane failure, only a piece of rock slides against a plane, but in wedge failure it falls within the bench. Circular failure is of circular shape, and in toppling failure it is in part. Toppling failure generally takes place in soil and very loose rock. Next. Factors that affects pit slope stability. These are geotechnical property of slope, geological discontinuity of rock mass, groundwater and rainfall, geometry of slope, state of stress, erosion of the surface of the slopes due to flowing water, seismic effect, dynamic forces due to blasting and HEMA movement, slope modification, undercutting, presence of underground galleries, etc. Stabilization of slope. These slopes are stabilized by the following methods: drainage system, surface drainage system, subsurface drainage system. Means the accumulation of any water in open cast mines, either it has bench or bottommost surface, should be drained using suitable type of pumping system. Then stabilizing through support, ground inclusions, ground anchor, soil nails, rock bolt. And the stabilization through support means the support of the mines can be done by anchoring supports or wire net or by using rock bolt. After that, rock mass improvement and stabilizing method. This is geosynthetics. It is used by synthetic material just like grouting, chemical stabilization, biological stabilization. In grouting, cement mix are sent into the cracks or holes in the mines. Some chemicals also used to stabilize the ground surface, so that they bond the cracked or loose materials into single one. And biological stabilization, it is especially carried out on overburden slope, where suitable trees are planted. They control the any fall or failure of slope. Now, we come to design of haul road. During designing of an open pit, the first of all haul road is designed. Haul road, it must be maintained throughout the life. It is a travelling roadway, and it may be a spiral system. Haul road is arranged spirally along the perimeter wall of the pit. It depends on the geometry of the deposit and our working methodology. Yes. Some switchback system, it is zigzag pattern on one side of the pit. Haul road width, function of capacity of road and the size of equipment, and haul road must be considered in the overall pit design, because it is should be of two lane system, as the heavy machinery like dumper or haul pack is continuously moving on the haul road. So, one is moving forward and other is moving backward. So, they may meet at a point and there should be sufficient gap between these two vehicles. So, the haul road width should be of sufficient size dimension, so that there is sufficient space for the movement of vehicles. Yes. Haul road design, consideration for haul road design. Visibility, first of all we have to maintain the visibility along the roadway. There should not be so much turning or abrupt area change or abrupt dimension change. Every vehicle should be visible from the nearby moving vehicles or nearby moving workers. Then a stopping distance, the distance between two consecutive moving vehicles should be sufficient, so that after applying brake of one vehicle, the other should not get collided with that vehicle. Then vertical alignment, the road should be sufficiently aligned, smoothly aligned, such that during turning the avoidance of slippage of vehicle may be happen. Then horizontal alignment, this means curve. The curve should be made such a way that super elevation should be maintained, so that the vehicle can move without any accident or any slippage. Cross section, the cross section of the roadway should be such that should be of made such type of material that keep the stability of the roadway, and minimum maintenance may be required. Runaway, this is related with vehicle safety provision, that is movement of vehicle in such a way that vehicle during movement should be safe. These are the parameters. Particulars: width should be facilitated two-way traffic, that is two lane traffic, dozer movement, formation of drains, lighting arrangement, normal width 30 meter, but depends on the capacity of dumpers. Generally width of roadway is 30 meter, it may also depend on width of dumpers. Gradient 1:16 and maximum up to 1:10. In flats, mine waste dump. Now, come to mine waste dump. The overburden of waste and economic mineralized rock is required to be removed to mine the useful mineral resource in a surface mining operation. In this process, a dump is formed by casting the waste material and dumping it in nearby area. The dump so formed is known as mine waste dump. It is the place outside the boundary of the mine where waste is dumped on that place. Waste dump may be classified as internal and external dump. External dump is created outside the pit, whereas internal dump is created inside back of the mining area. These waste rock dumps are heterogeneous in terms of grain size and structure. Now, come to ultimate pit design. This is the final pit design. the contour which is the result of extracting the volume of material which provides the total maximum profit while satisfying the operational requirement of safe wall slope. The ultimate pit gives the shape of the mine at the end of its life. An ultimate pit limit looks for the blocks that will be mined and those that will not, thus outlining the part of the deposit that can be mined economically and safely. In an effort of identify the blocks to be mined, an economic block model is created first from the geological grade model. This is the floating cone technique or computerized model to determine the ultimate pit design. It is another task for a given open pit mine that what is its final dimension, means what should be its width, what should be its length, what should be its depth. If width and length are not considered, then depth must be considered, because we have to move our machinery and it is directly related with transportation cost and mineral excavation cost. That is why it is very carefully designed. Optimum pit design plays a major role in all stages of the life of an open pit. At the feasibility stage, where there is a need to produce a whole of life pit design, means feasibility study stage means possibility. We consider first of all what are the possibilities that the parameters, if we apply, we can get a maximum profit at minimum cost. The parameters, some parameters are controllable, some are uncontrollable. The uncontrollable parameters are natural parameters, that is, that has already mentioned, the shape, size, dimension, quality of deposit, strata, like, and the controllable factor is deployment of machinery, selection of method, waste dump technique, etc. In the operating phase, when pit needs to be developed to respond to change in metal prices, cost, ore reserves and wall slopes, and towards the end of mine's life, whether the final pit limit may allow the economic termination of a project. This means whenever the cost of mineral becomes low, then our working will be in loss. If the cost, the price of metal becomes high, then our working will be in profit. So, the metal price, the cost of operation, the quality of ore reserves plays an important role for the calculation of profit obtained from the open pit mines operation. So, we calculate net present value at every stage, and if net present value is 0, means it gives no profit, no loss. So, net present value should be positive, then we can get profit, but if net present value is negative, we cannot get profit and the whole operation should be terminated on the basis of economic consideration. At all stages, there is a need for constant monitoring of the optimum pit to facilitate the best long term, medium term and short term mine planning and subsequent exploitation of the reserve. Means we have to constantly pay attention towards the break even stripping ratio, economic stripping ratio, net present value, mineral prices, taxation, cost of operation, maintenance of machinery, time, so that the whole operation is associated with cost and revenue. If revenue is higher than cost, we have profit. If revenue is lower than cost, it will be loss. So, the break even stripping ratio and economic stripping ratio is continuously determined at different interval of time, and then we move forward or stop. The optimum ultimate pit of a mine is defined to that contour which is the result of extraction of the volume of material which provides total maximum profit whilst satisfying the operational requirements of the safe valve. The ultimate pit gives the shape of mine at the ends of its life. Usually the contour is smoothened to produce the final pit outline. Ultimate pit determination in each period of a time is a function of financial affairs. This function is well defined by break even stripping ratio. Now, revenue from ore can be obtained by ore grade into recovery into selling price per ton. As grade is constant and recovery and selling price of ore is variable, we can control it, and cost of production is mining cost plus processing cost. If mining cost is high, production cost will be high. If processing cost is high, naturally mining production cost becomes high, and naturally it affects break even stripping ratio. These are the some of references: surface mine technology, Sagardeep Prakashan, Kharagpur; D.J. Deshmukh, elements of mine technology; and B.A. Kennedy, surface mining; William Hurst, open pit planning and design; J.B. Mishra, surface mining; Flyder, open pit mining; R.D. Singh, peaceful practices; Ratan Raj Tatia. And we say that during design of open pit mine, we have to design the parameters of open pit mines like haul road, bench, stabilization of slope and calculation of economics towards the revenue obtained from ore and cost associated with mining operation. As we see that the cost of removal of overburden, cost of extraction of ore and processing cost can also be calculated and added to whole, give a name the cost of mining operation, and the selling price of selling price of ore and gives the revenue obtained from ore, and this revenue minus cost gives the profit or loss, and that gives the ultimate open pit design of a mine.